Hello everyone, we are Team 3. Our topic is to detect the post on the Reddit. We choose two similar subreddits. One is Wall Street Bets channel and the other one is the Investing channel. Here is our project overview. In the middle presentation, we already covered the first four sections, and we're going to mainly focus on the last four sections today. The goal of this project is to help the stock investor to know the post is from the stock investment experts or the amateurs. To do that, we would like to use machine learning techniques to build some models to detect the post from these two subreddits. So we hope it can help the investor to make the right decision before the trading. For the data collection, we use the PushShift API to extract about 20,000 posts from each subreddit. And here is some sample of our raw data. Left is the Wall Street Bets channel and the right one is the Investing channel. This is the word cloud, contains 50 words from these two subreddits title. Bigger words have higher frequencies in the title. We used 4 different models to predict this post: naive Bayes, logistic regression, KNN, and random forest. We will introduce each model and compare them based on their performance. And next, it will begin with the model pipeline.
So here's overview of our entire project process. So we'll start with the TF-IDEO vectorizer, and then we will run 4 separate machine learning models. And then after that, we will put them together through a rolling classifier and evaluate the performance. So the first step, data preprocessing. So we create a new column called class, which assign each post Reddit channel into different class numbers. So Wall Street Bet is 0, investing is 1, and then we select title, which includes all the text and class columns and merge the data set. And then we drop the duplicate rows and reset the index, as well as tokenizing and stemming the title columns using Stovall stemmer, and adding the stop words to the model, including words such as S, M, D, is, the insignificant words, as well as the pronouns. And last step is to train the test, split the training and the testing data sets. So the X data will be the title and the Y is the class. So some of the Python package we used in this process is our NLTK and sklearn. So the first model we use a TF-IDF vectorizer. So this is a pre-processing model, and it's the full name is term frequency inverse document frequency. The term frequency calculates the count of words in one document divided by the total number of the words in the specific documents. And the IDF calculates the inverse document frequency, which is the logarithm of the total number of docs in this entire collection divided by the number of documents that has the specific words. So the formula, as you can see on the right, outputs the weight for the specific words. And this entire process reformat the text data into a number of numerical vectors so the machine learning model can read. So next slide, the first model we built is probability-based model, and we chose Bernoulli naive Bayes. The reason why we chose this model is because Bernoulli distribution is best fitted for a binary classification, as you can see from the formula below. So basically, the formula is the probability of x times x plus the 1 minus the probability of x times 1 minus x. So this formula will output 2 probabilities. So for each class classification, the class with a higher probability than 0.5 will be assigned as a prediction. And then moving on. So in addition to running the model in default parameters, we decided to tune in the alpha parameter a little bit using grid search. So here we can see that the alpha here means the smoothing is a smoothing technique using a naive Bayes, as you can see from the formula below. So the alpha here mainly represent the k under the formula, and then the default input is 1, but through a various attempts in the grid search, the best output appears to be 0.7. And now let's take a look at its the sample code. So as we can see here, we use the pipeline parameters and grid search from sklearn. And the pipeline you can see we build with the TF-IDF at first, and followed by the Bernoulli distribution, Bernoulli naive Bayes. And the parameter input is alpha in a range from 0 to 1.3, and each integral is 0.1. And the grid search, we put in the pipeline as all the parameters and using accuracy as a score. And then we run cross-validation 5 times. And the next slide shows the report, the performance using classification report. So as we can see from the classification report, the model's accuracy is 80%. And then 0 represents the class 0, which is Wall Street Bets, and class 1 is R investing. So as you can see here, class 0 has a precision score of 0.79 and recall 0.82, and class 1 has a precision of 0.81 and recall 0.79. So precision measures the false positive, while the recall measures false negative. So according to the score, we can see that Wall Street Bets has a higher number of false positive than false negative, given the value of a higher recall than a precision, while class 1 investing is the reverse. F1 score shows the total number of false positive plus false negative, which is the underlying formula for accuracy. So as you can see here, class 0 has accuracy of 0.81 and class 1 has 0.8. So that means that when a model predicts Wall Street Bet, its accuracy is 1% higher than predicting R investing. And then next, we're looking to the second model.
So for the logistic regression, at first we ran the pipeline without any parameter. The test accuracy is about 0.803. We can see the performance here. Class 0 has higher precision than recall, and class 1 has higher recall. The F1 score are the same of these two classes. And then we do the, we set few parameters with different values for the count vectorizer and use grid search to see which value will have higher performance. The first parameter is max DF, which means the maximum document frequencies word must have to be used as futures. N-gram range is a string of n words in a row, and we have to put the minimum and maximum size of n grains we want to include in our futures. The last one is stop word. We just put the noun and English for that. And here's the best value for each parameter. The accuracy has increased a little bit to the 0.808 compared to the default pipeline. As we can see here, the precision of class 1, recall of precision of class 0, recall of class 1, and the F1 score for both classes also increase a little bit. And then we do the same thing for the logistic regression classifier. We also put 3 parameters here. The first one is penalty, which is to specify the norm used in the penalization. L1 equals to the absolute value of the magnitude of coefficients. L2 equals to the square of the magnitude of coefficients. So the third one here is combined L2 and L1. C is inverse of regularization strength. Higher C gives more freedom to the model. Max iter is maximum number of iteration taken for the solvers to converge. And here's the best value for the parameters. The performance is almost the same as the previous one, but we've got the higher accuracy for this model is about 0.81, and it is also the highest accuracy among all of our 4 models. Next is the KNN model.
The third model we ran is similarity-based model KNN. It is used the distance to find the k nearest the neighbors for the test target. We first ran it with the default model for both TF, IDF, and KNN. The default parameter for KNN model is n neighbors equal to 5. Weight is uniform, which means all points in each neighborhood are weighted equally. Algorithm is auto. It will attempt to decide the most efficient algorithm based on the value passed to fit the model. The left figure shows the code and the right side is the result. So as you can see, the accuracy is 0.55 for this default model. Then we start the TF-IDF turning like the other models. We add some parameter and the result is increased to 0.63, which is 8% higher than the default model. For KNN turning, we choose 2 parameters, a neighbor and weight. A neighbor, we choose a number from 1 to 21, and the weight is uniform and distance. So distance means closer neighbors of query points will have a greater influence than neighbors which are far away. So since we have about like total in 200 feeds, we move the TF-IDF step out of the greedy search to save time. So the right side is so the next model we use is information-based model random forest. For default model, the accuracy is 0.79. Since the TF-IDF turning shows the same result, we still use the default TF-IDF for random forest turning. The two parameters we choose is n estimators and max dips. N estimators is the number of trees in the forest. Max dips is the max dips of the trees. The bottom is the sample code. We have total 75 feeds for this turning. So the best parameter is 500 for an estimator. And the max dips is none. The final report shows Wall Street Bets has lower precision and higher record than investigation. The F score is similar and the accuracy is 0.79 for random forest model.
So now we have 4 machine learning models, and each model represents a different learning algorithm we learn from class. So now we will compare the performance of these 4 models. And this slide shows the confusion matrix for the 4 models. We are interested in confusion matrix because we want to know the false negative and false positive values beside the test accuracy. So for example, the false positive value shows that how many posts should belong to the Wall Street Bets that are wrongly classified in the investment. So in the figure, we can see for the KNN, it has the highest false negative value compared to the other models. And for the true positive values, this 4 model looks very similar. So next slide will show the evaluation of the models. For the test accuracy, the logistic regression have the highest score, which is 0.81, and KNN comes last. For the F1 score, both the naive Bayes and logistic regression have the highest score, which is 0.81, and come the random forest, last is KNN. So beside with the single models, we also try to use ensemble technique to combine these models. So next we will use voting classifier to combine these 4 models, and our code is showing below. So next slide will show how voting classifier works. The figure on the right shows that if we have a new instance, we train our model and each model give a label to the data. We will get the final label of the data with the majority votes of the model. And this table below shows the results, including the voting classifier. So as we can see, the test accuracy and F1 score does not increase when we use the ensemble model. So we will try to see the confusion matrix next. So these 2 figures shows the train and test confusion matrix of the voting classifier. We all see the figure on the right. So for the true positive value, it increased 5% compared to the single model. And for the false positive part, it significantly decreased by 21.8 compared to a single model. So we know that we use the ensemble technique, we can reduce the risk of detecting the false positive part. And next, I will pass to Kevin about the word analysis.
So after our model performance, we decided to evaluate to look more into the false positive and false negative, as in why would model determine those posts differently in a mistake. So the first technique we use is LDA analysis. So LDA output assigns each word into a number of topics and attributes, and output is the importance score. So the topics over here are the 2 subreddit channel, Wall Street Bet investing. So as you can see from the first table, so with the column is with the rows as the Wall Street Bet investing topic, each word shows its different columns, and the listed are its importance score with regard to each topic. So as we can see here, account has about 381, to Wall Street Bets, well, it's 0.59 for investing. So which means it's more important to Wall Street Bet channel. And then this first table will lead to the second table, which outputs the top 15 most important words in each subreddit. And as you can see here, there are some nouns, stock names, as well as pronouns, verbs. So the next slide, we look into false positive, false negative separately, as in terms of which the most frequent word appears in each categories. So false positive here means that the Wall Street Bet post but predict as investing, while false negative is the investing post predict as Wall Street Bets. So false positive is shown on the left in blue, and the false negative is shown on the right in red. And as you can see here, a lot of words from the left side are actually important words from investing subreddit channel, as we can see from the previous table. And the same situation we can see from the right, that a lot of important words from Wall Street Bets are shown up in our investing post, which makes the models confused and predicts in the opposite classification, in the opposite subreddit channel. So some examples from the left, such as invest, buy, and help, and on the right side, such as moon, GME, hold. So the next slide. To sum up what we've done so far, so we first use PushShift API to extract data from two subreddit channels, Wall Street Bet or investing, and then we'll use TF-IDF vectorizer as pre-processing to turn text data into numerical vectors. And then the next step, we used individual machine learning models to train on these posts to distinguish them from each other's. And then the last step is using voting classifier to ensemble them together and evaluate the results. So if given more time in the future, we will look into the sentiment analysis to see if there are any relationships or trends between user activities from each subreddit channel to the actual market fluctuations. And next will show us demos that we've done so far. Can you see the screen?
Mm-hmm.
Can you see the screen?
Yeah, we can see it.
Okay, cool. So the first is, this is the demo, this code we use for voting classifier. So as you can see, the first step is importing all the libraries, and we include NLTKs for the natural language processing and the different models that we use from sklearn package. First step is reformat the data. So we import two data sets, one's Wall Street Bets, one's investing, and assign class, a new column to each. And then we chose title and class from each data set, and then we combine them together. And drop duplicates, reset index. And then here, this step is imply the stop words using snowball stemmer and then manually adding some insignificant pronouns. And here, the first step is tokenizing it. So we only choose the alphabetical words from it, and also we lower all the capitalized words. So the output here should be alphabetical words in terms of list. So then we distinguish X and Y data sets, so title and class, then we train test splits. And the evaluation function here, so we like to use the best score, best parameters from grid search, and then we will use the prediction to see the prediction scores, the accuracy. And then this is a product confusion matrix. This is model visualization. We'll use the confusion matrix that shows the train and test data set and performance of false positive, false negatives. So here's an ensemble model. We'd like to try it's a voting classifier. So the first thing is the TF-IDF, the preprocessor, and then the estimators. Here is the models we're including in the voting classifiers. We can see Bernoulli, logistic regression, random forest, and KNN. So we group them into VC, voting classifier, and then we build a new pipeline, which included TF-IDF as well as a VC voting classifier, including all these estimators. And then we use grid search to include this entire pipeline, and then use a cross-validation of 5. And here's the running. We use the model to fit on the X train and Y train. And here's the evaluation score. We can see the accuracy from train data set is about 78%. Test data is about 78.8%. And then here shows the classification reports, precision recall and F1 score, and the confusion metrics for trained data sets and test data set. As we can see here, is a lower number of false positive, but increased number of false negative. And here's the model evaluation that we did after the model building. So we can see we use the LDA. Well, actually not here. So first we can see we include all the prediction into a new column here, and we can see each different post, their original assigned class, and then their prediction. So As we can see here, this is an error, class is 1, prediction 0. And then we put all the false positive and false negative into different data frames. So as you can see here, this is false positive, all the class strip, do Wall Street bets, put predicted as investing, false negative, reversed. And then we've output it's a most frequently used words with n-gram equals 2. So we can see E-Trade, stock shock, short squeeze, so that when we're using the slideshow, and also we tried on the single words, but it doesn't really hold too much meaning. So we have to use the 2 words phrase instead. So this is our overall demo, and this will be it for our presentation.